I suppose. So it will be a nice, it will be a nice discussion, a nice talk, sharing our experiences together. काफी लोगों के भी यहाँ पे बोर्ड के एग्जाम्स रहे होंगे. So for that matter, we can just talk here. And aside from that, there are always welcome physics questions and maybe even mathematics for that matter. So just wait for some people. Regarding, all right, that is Sakti FF. Hi, hi. Dark Energy. Hi, hi. So that's a cool name. Dark Energy, cosmological constant. Unreal OP, hi, hi. Agent Y equals A sine omega t plus phi, hi, hi. Unique Adil this side. Hello Adil. That is Anurag, Kamini Gupta, Muhammad Owais. How much percentage are you expecting? Well, honestly, truth be told, I think I'd expect like around 85%. Kamini Gupta, hi, hi. Free Fire 1234, hello, hello. Mohammad Arham Akhtar, Assalamu alaikum Sarim, wa alaikum assalam. And that is Harnoor Singh, hello bro, hello. Unique, your father looking so cool. Yeah, he's kind of cool.
Father है बेटा cool रहना पड़ता है.
Kamini Gupta, how much percentage are you expecting? Well, as I just said, I'm expecting around like 85. Muhammad Sadruddin, which book should we solve in 10th in keeping in mind the JE preparation? Well, I wouldn't really say that when you're in 10th, you have to much keep in mind JE prep. So it's like, agar tumhe 10th, if you're talking about foundations, so that doesn't really help. Books होती हैं जो कि foundations के लिए होती है 9th and 10th से 6th से 7th से, but that's effectively useless. It doesn't have any use at all. If you have really interest in that thing, well, go ahead. But foundations are useless, I would say. If you're solving the actual stuff, मतलब जो 11th and 12th की actual stuff होती है, so in that case you have to go with actual, मतलब जो books actually JEE aspirants solve करते हैं, JEE toppers solve करते हैं, HC Verma for that matter. So ये kind के books, foundations are effectively useless. So if you have to solve, well, solve those. Otherwise, there is no need to. हरनोर सिंह, ब्रो मैंने सिंगेज और पियर्सन खत्म कर दिए, अब बताओ क्या करूं? Well, I don't exactly know which book you're referring by Pearson, क्योंकि Pearson is Pearson is a publication, and so Singage, but so is Singage. But by Singage, I think you're referring to B.M. Sharma, as I recall. I don't exactly know the author. So that is very good. If you have finished that, make sure that you can do the stuff yourself instead of relying on solutions manual. Because if you have done that yourself, then you're basically prepared for what questions are to come. It means that you have mastered that critical thinking, that style of thinking that is necessary to solve those problems. And once you've mastered that, you can solve any problem that comes along the way. So make sure that you can do it yourself and you know how to do all the derivations yourself. If you can do that, well, you're ready for JEE exam. If you can solve all the questions in HC Verma by yourself without having to rely on any coaching institute for that matter, because coaching institutes will give you straight out all the derivations and they'll not make you really solve that yourself. So be aware of that. If you can do everything yourself, so in that case, you are ready for JEE main or advanced, because what actually matters is that you know the concepts. You know the concepts and you know how to apply them. And solving HC Verma, the exercise of HC Verma only if you are able to do them yourself and every derivation that comes along. So you're ready for that. Here, there was a question regarding relativity. I'll look for that. Dark energy, when you're going to learn relativity proof. There is no proof for relativity for that matter. You don't prove things in physics. You prove things in mathematics, not in physics. You give evidences for things in physics. So there's a difference. Once you prove something, actually, so by the various methods of mathematical proofs we have, It means you finalize that matter, provided that the proof is proper, it's correct. You finalize that matter that it is true for the given class of systems. That does not mean that we can prove theories in physics. You're never going to prove a theory in physics, but you can disprove a theory by a single shred of evidence, but you cannot prove a theory. Regarding evidence, well, I know about pretty much evidences for relativity. I wouldn't say I've mastered relativity really. So yes, I plan to master that. I plan to master gravitational physics. Oh, Pranab Deogharia, did you watch Champions Trophy? No, I don't. यहाँ पे Mohammad Owais, did you write NSCP? No, I actually didn't write NSCP. All right, there is another question here on QFT. I'll answer that just now. The thing is that NSCP requires, I saw it, that NSCP requires having to have memorized too many formulas as I saw. So I didn't focus on it quite now, and I am not sure I want to focus on it right now. Maybe this year I might want to, but I don't really have any such plans at the moment. So I had initially thought of Olympiads, and I had looked at IPH, and well, the questions were interesting. But the problem for me was the very first stage, and me to that would require me to practice, which I'm kind of well slagging on, I would say. So it would require me to practice those particular form of questions under time constraints, which I absolutely suck at, and having to memorize formulas so I can quickly apply them. So I'm not really good at that kind of thing. I can solve whatever problem that is, but not under strict time constraints. So maybe I write it this year, but I don't have any specific well goal in mind regarding that. All right, this is Rinku Jha. Please tell me that in quantum field theory, the density of vacuum energy is infinite. Am I right? Yes, and that's the biggest problem of unifying quantum field theory with gravity. Because, well, here is a simplified explanation. You have in quantum field theory the density of vacuum energy is infinite, which should mean that space-time should be infinitely curved. So if a space-time is well infinitely curved, we are not really observing that, are we? And that basically means that somehow there is a contradiction between the two theories, or between how the two theories model the physical universe, because we can very well work out quantum field theory in curved space-time. That works well, in fact well, for almost all the cases that we know, and it is called semi-classical gravity. So here is what you do, that you take the Einstein field equations. On one hand side of the Einstein field equations, you have the Einstein tensor. Let's ignore cosmological constant. That's a big issue in this frame. Ignoring the cosmological constant, you have the Einstein field equations. One hand side Einstein tensor, which speaks of the structure of space-time, and on the other hand side, you have the stress energy momentum tensor with some constants attached. The thing is that stress energy momentum operator, which concerns matter and energy, has to be a quantum mechanical operator. So you consider that to be a quantum mechanical operator, because we know observables are supposed to be represented by operators in quantum mechanics. The Einstein tensor is well a physical quantity, because it has to do with the structure of space-time. So what do you exactly do? Well, turns out we cannot exactly renormalize this thing. So what we can instead do is we can equate it such that you have the Einstein tensor on one hand, and that equals the expectation value of the stress energy momentum operator. And that's how we work this thing, quantum field theory in curved space-time. This kind of gravity is called semi-classical gravity, and it works well for almost all the cases. Almost all the cases that you can work on in laboratory, it works perfectly well. Gravity is such a weak force that we cannot exactly go beyond these levels where we logical constant. Instead, we get infinities as result, which is called the cosmological catastrophe. So, which is by far the worst prediction of quantum mechanics that we have. Shivam Kumar, who is your favorite physicist? So initially, I would say Newton. I said for a while Einstein, but after having studied physics more properly, so that was all popular science and all stuff. Again, they are the two greatest physicists, I would say. But actually, having further studied in depth, I would say now Dirac. So Dirac's works. So whatever I've seen of Dirac's works, that amuses me the most. I would say it's Paul Dirac. That's Paul Dirac. I also like Lando. I've been liking Lando quite a lot recently, but maybe just due to the Land of Lishit series. And I am particularly amused among recent, I'm most amused by Hawking's work, undoubtedly. So I'm most amused by Hawking's work among the recent physicists. Penrose, he is my favorite physicist alive. Overall, I would say is Dirac. And yes, not to mention Dirac's 1933 paper, The Lagrangian in Quantum Mechanics, I say it's one of the best papers ever. That laid the foundations for Feynman's path integral formulation. Penta India, brother, I have scored 98.103 percentile in mains J and 96.2% in 10th. Are they good from a third person's perspective? Well, as from what I hear, 96.2% in 10th as well. Really good. Regarding 98.03 percentile in JEE means I don't really know. So I don't really know how much marks do students typically score or what percentile is typically good. So I can't really say about that. I mean, I need to have a measure of how much others are scoring, and I don't really know. Ledge IT, bro, what do you think? How much is your IQ? I don't really know, and I don't really care. I mean, it's very one dimensional, I would say. So you're basically measuring how good someone is doing based on this series of questions. So that's pretty one
Below
dimensional.
100?
Below 100, no.
No, below 100 though.
Did you write IOQM? No, I didn't write NSCP. I told no way I'm writing IOQM. Was the paper tougher than previous years? Sharan Akshat, if you're talking about my 10th board exam, so I don't know. I didn't even look at the previous year question papers, truth be told. I did see the sample papers of this year. I didn't solve them. Instead, I used the sample papers to study whatever type of questions will be there and to focus on that. The last night, of course. Um, Please suggest some English grammar and speaking books, please. Pranav or Deogharia? Well, I am not really sure. I mean, I never studied English grammar formally. So if I know how to, well, create sentences the proper way and all that, so it's by reading books on physics only, right? I don't think there is any particular book that would be useful for that matter. If you plan to learn English, if you plan to speak English, the thing is just practice. That's the thing, and people are going to correct you anyways. I mean, look at the number of people who are correcting my arithmetic mistakes on my boards videos. Ledge IT, what are your plans for future? Do you want to do patents, inventions, theories, or so? Patents and inventions, no. Theories, yes. So I plan to be a theoretical physicist. Bro, if I get 80 to 90% in 10th, will it affect my JE prep? Because my bio and SST is very poor as well as chemistry. Heard Noor Singh. So you can set aside bio and SST. You'll have to improve on chemistry for that matter. And I don't think your scoring between 80 to 90% in 10th is going to affect JE prep anyhow. I mean, they're not remotely connected.
जो हिंदी में लिखता है ना बेटा उसका आंसर
Yeah, nobody wrote that in Hindi until now. Logic, what are your thoughts on philosophy? Is it helping humanity in any case? Well, I haven't really studied philosophy properly. I cannot say regarding the philosophy of natural sciences, philosophy of physics, I'll say on that. So, Feynman said to this, I don't recall what exactly the name was. He named a study, which is the study of birds, and that philosophy is as useful to physicists or scientists as useful. So, name is to birds. It doesn't really matter. So, if you're considering things like moral philosophy, ethical philosophy, and all those matters, they are useful, I would say. You can actually understand the world properly. Philosophy of physics, not so much. But again, there's this thing that oftentimes the problems of physics fall on the edge between physics and philosophy. So those are matters, interesting matters, especially one matter that I'm really interested in, the measurement problem of quantum mechanics. So it was there on the edge of physics and philosophy, even though I say that it's completely a physics because there is a fundamental inconsistency in the theory of quantum mechanics. Yet most of the people would consider it to be rather philosophical. But I would rather say it's physics, really. So the philosophy of physics is not that much of concern, I would say. Not in PC gaming. Did you give national standard examination of physics? No, I already explained that in the very beginning. I didn't. No, Singh, tell me about Heisenberg's uncertainty principle. Well, it's basically that you cannot measure both the position and momentum of a particle simultaneously with exact accuracy. In fact, with greater than an accuracy that is well given h bar over 2. So that's the product of their standard deviations has to be greater than or equal to this particular number. And I think it's rather misunderstood how the Heisenberg's uncertainty principle is explained. So first of all, the uncertainty principle, as was first worked out by Heisenberg, that was worked down in the quasi-classical case. Quasi-classical as in almost classical. So Heisenberg actually works it out in the quasi-classical case. It was Weil who worked out the uncertainty principle, Heisenberg's uncertainty principle, that of position and momentum, in the form that we know today. And Bohr gave a particular explanation for this, which is still repeated today and which I thought for a time to be true, which is outright wrong. It's not incomplete, it's not incorrect, it is outright wrong. What the explanation is. So let me recite this completely wrong explanation once. You have a particle, and to view its position, to know where it is located at, you need to hit it with a photon with light. And to view it with greater accuracy, know where it exactly is, you need to hit it with photon of higher energy and therefore higher frequency. That's how they're related. When you do that, it has high energy. The photon also carries higher momentum and high energy. So the photon will scatter, disturb the electron. And so the photon is going to disturb the electron more. And so you know its momentum with greater accuracy. And if you want to know the momentum with if you want to know the momentum with greater accuracy, in that case you'll have to hit it with smaller amount of energy, in which case you cannot know exactly where it is located at, and all that rubbish. So Bohr gave that explanation, but we didn't really have much understanding of quantum mechanics back then. That's outright wrong, because in this case you could basically tell how the photon is going and interacting with it, and given initial conditions you could actually work out the final conditions of that were the case. That is not a quantum mechanical case. The actual thing is that position and momentum operators don't commute. Now this is a technical explanation, I know, but that's exactly how we know how we can explain quantum mechanics. So I don't think we can explain it. I can explain it any better. So the top experts, of course, can. So this is basically uh, how you explain the Heisenberg's uncertainty principle. You have the position operator and the momentum operator. When I say they don't commute, what this basically means is that the particle cannot exist in a state where it has also a well-defined value of momentum and also a well-defined value of position. So when you try to pin it down to a state where it has, where the range of momentum values is small, you will essentially put it, that state will essentially be a state where the range of values it can take as its position is much. and vice versa. So that's the actual explanation of the uncertainty principle. Not just that it's not just that you cannot measure it, it simply doesn't exist. That's the state of the particle. The state in which it has a smaller range of values for position, it will have a larger range of values for momentum. And this can be worked out very nicely using the concept of Fourier transforms in mathematics. So you can use Fourier transforms of mathematics to derive the uncertainty principle right away. That's one of the most amazing connections between physics and mathematics. So here is Unique, who has given a 20 rupees super chat. Really, thank you for that. All right. Aryan Mishra, how many hours do you work? Well, it depends day to day. So if you're talking about physics, it depends day to day. I wasn't much productive today, really. I just looked at some things in Lagrangian and Hamiltonian mechanics and some path integral. That's it. On the other hand, yesterday, yeah, I slept most of the day yesterday because day before yesterday I had my exam. So it just got over. On the other hand, the day before that I worked quite a lot, and the day before that again I studied quite a lot. So it varies day to day. How's your Hindi exam, Premnath? Well, contrary to what I initially thought, it was rather good. Brother, how can I improve my mechanics? Harnoor Singh. It's easy. Just understand that all you have to do is, well, here are three laws of Newton, and you have to derive everything from that. Just do this thing that you understand the motivation for the laws of motion and kinematics. Take these two things, understand the motivation behind them, why you need speed to be like that or laws of motion to be like that, and then try one by one deriving every single thing next. All right, that's it. So you have the laws of kinematics and the laws of motion. That's it. Try deriving every single thing. You'll get better at it. You'll understand it. Karan Nalawat, do you get bored or feel burnout while studying physics? Obviously, I do. I'm studying maths in college and it is quite boring and abstract. How can I revive my interest in math? Well, regarding math, the abstract part is absolutely true. I do get burnt out while studying physics. I mean, sometimes it is a straight out, well, yeah, there is simply so much of it. And you have people like Witten and Hawking absolutely rocking these things, and you just cannot understand their works, right? Even to reach to that level where you can understand people like Witten and Hawking. So that's how I get demotivated. So especially these two physicists whose work, whenever I look at Ed Witten and Stephen Hawking, so that absolutely demotivates me. I cannot even remotely comprehend that. So, but again, eventually there is something that you work out properly, like solve a path integral. So that will motivate me. So that's basically how I get motivated again. How you can revive your interest in math? Well, just I mean, look, you can do so many things, right? If you're in college, I'm pretty sure you have learned linear algebra by now. So you have learned how eigenvalue equations work and all that. So you basically you can understand one aspect of the world using that, right? You're basically able to understand. If you know linear algebra, you know that is the language of quantum mechanics for that matter. So you have understood one aspect of the world with that. In abstractions, certainly, but it is quite useful and it is quite, well, beautiful for that matter. So the thing is, whenever I do feel demotivated like that, I think back that when I'm looking at the fan, I can understand how the fan works and I can model it using physics and mathematics. So that is motivating and inspiring. Another thing, I can, well, calculate how much light deflects when coming from a distant star and passing nearby sun. So that is quite motivating that I can do all these amazing calculations, amazing stuff using physics. So that is quite inspiring for me. Maybe you could try thinking over that.
Are you saying that what is the difference between the magnetic waves and matter
Harnoor Singh, what is difference between electromagnetic waves and matter waves? This question was asked by my teacher, but I didn't get the answer. Well, matter waves, I hate the explanation that most people give for matter waves for that matter. Matter waves are like, how do I explain this? They're not real. there are no real matter waves. They concern matter. In essence, you can attach a kind of wave to every form of matter that you have, like an electron or a proton that basically has a momentum. They are not real. There's nothing traveling through physical space like that. Although there are some interpretations of quantum mechanics that say that, but the standard interpretation that we have, the Copenhagen interpretation, so what we call the textbook quantum mechanics, it doesn't have that. There are no real waves traveling. It's a probability wave. The web doesn't exist in physical space. It doesn't travel in physical space. The kind of web that you're attaching to it's a probability web, and the amplitude of that web tells you what probability. In fact, it is the amplitude square, but those are the technical details. That basically tells you what is the probability that you'll find an electron somewhere, right? Or that you'll find, you can do some mathematics with it, some calculations, and it will tell you what is the probability that you'll find the electron with this value of momentum or energy or angular momentum and all that. So the kind of matter waves that you learn about, de Broglie's waves for that matter, they are actually probability waves. Now, de Broglie had his own theory that we call now de Broglie Bohm theory, the pilot wave theory also. So in that, the matter waves are actually there, but we have not been able to detect them. So the standard theory of the standard interpretation that we believe in, it doesn't have those matter waves to be physical. It is a probability wave. The electromagnetic waves are again, and there's nothing physical, but this concerns the electromagnetic field. The matter waves are something concerning that you can attach these probabilities to every particle regarding their position and momentum and all those dynamical variables. The electromagnetic wave is a disturbance in the electromagnetic field that propagates through space. So there's an actual disturbance propagating here. There's no actual disturbance or anything actually there in the case of matter waves. Aryan Mishra, have you read the autobiography of Charles Dirac? Well, I'm not sure Charles Dirac. If you mean to say Paul Dirac, no, I haven't read that yet. And I don't think Dirac would have written an autobiography. There are biographies, of course, but there I don't think Dirac would write an autobiography, really. That's not just not him. Harnoor Singh, brother, can we get AIR under 100 if we study 16 hours per day? Well, the content is what matters. It matters how much you have prepared, not how much you have worked. I mean, the end result is that how much you prepared, and according to that, well, uh, you can get your well corresponding rank. So if you prepare properly, strategically, you can basically get that. I mean, it's not impossible. Perfect. What is power of your specs? I don't really know. So one by whatever focal length it is. Uh, Chaitanya Mathuria, how I start quantum physics with class 12th. Well, that's mathematics, of course. I mean, I like to say this, maybe to these people. So, quantum mechanics is like the easiest part of physics. So, now it certainly is not conceptually. Mathematically, it is. Like, the mathematics of quantum mechanics is really easy. But even when I say the mathematics of quantum mechanics is really easy, I still mean you need calculus 1, calculus 2, and calculus 3, linear algebra, and differential equations to study it. So that, but this is really easy compared to some other branches of physics. Classical mechanics, when you study, so it gets really complicated on the mathematical front when you study classical mechanics proper. So by that I mean what you call Lagrangian and Hamiltonian mechanics, or analytical mechanics, what you call analytical mechanics as a whole. So that gets really complicated on the mathematical front. So, but you will have to still go through calculus 1, calculus 2, and calculus 3, which basically means single and multivariable calculus, including vector calculus, which is like really important, and linear algebra and differential equations. The content of linear algebra that you actually need, you can learn in like a day, but you'll have to devote some time for it. I mean, I learned most linear algebra that I needed when studying quantum mechanics in a in a day. I really did that, but not like I actually understood it proof based. I just learned the stuff I needed. Then there is our differential equations. So if you're preparing for a IITJ or something like that, then that will be really difficult, and I would not exactly recommend. If you're really interested, then I would say try um, introducing yourself the subject to the subject with the third volume of Feynman lectures. So that doesn't get very complicated mathematically. It's really simple and it basically gives you an introduction to the subject. You won't be able to calculate quantities with that, calculate stuff with that, solve the Schrodinger equation much, but you can get a kind of overview of the subject. The actual stuff comes with more complicated books, not exactly complicated, but comparatively speaking, books like Griffiths you have and all that. So again, if you have mastered the mathematics, you can go ahead with it. The subject is well easy on the mathematical front once you know all that. To actually understand the stuff on the conceptual front is kind of uneasy and is kind of difficult. Not the entire part, but one part you'll come across the part of measurements, and that's well really difficult. And I absolutely cannot wrap my head around it, and I go crazy thinking about it. So that part is difficult. The mathematics is rather easy. How to start studying relativity, special and general as a beginner. Sumit Sharma. Special relativity is like easy if we look at Einstein's formulation for it. Even Minkowski's formulation, I would say it's easy really. General relativity is well kind of difficult, and when I say difficult, I mean really difficult. Like I just told how I consider quantum mechanics is very easy on the mathematical front. General relativity is absolutely the opposite. It's like so general relativity is like difficult, really difficult on the mathematical front. The mathematics of general relativity is differential geometry, and I don't think so. Differential geometry is most physicists who know general relativity won't actually know differential geometry in depth, and they won't know it proof based. They won't know it rigorously. So they only know the methods that they can use it in physics. Because if you have actually going to study differential geometry properly, so that's a really complicated subject on the mathematical fronts. I don't know how mathematicians would say about it. Maybe for their webs it is something easy, but considering from a physicist point of view, so it is rather advanced mathematics. So I can't really say much about that. Regarding special relativity, it's like any book on any book on mechanics for that matter, or even electrodynamics, will introduce you to special relativity properly. So Goldstein's classical mechanics does an excellent job on this. They introduced special relativity. They introduced the Minkowski's special relativity, uh, really good, really nicely. In fact, any other book, if you consider Resnick, Halliday, and Walker, or Resnick, Halliday, and Craig, so they will introduce you to Einstein's formulation of special relativity. Again, really good explanation. So you can start from simple books like that if you want to study special relativity. So Einstein's formulation, that this you can find in introductory textbooks. More advanced textbooks introduce you to Minkowski's formulation really, and the Lagrangian and Hamiltonian formulation. Regarding general relativity, it's more complicated. You don't learn that as a beginner. So once you have studied this and lots of other things, so once you have studied this and lots of other things and have really studied lots of mathematics, only then can you really get to that. So the difference in the levels of two is vast, like huge, enormous. Prashant, Piyush, who created this universe, every atom, energy, what is before the Big Bang, which where this ends in past? Help me, I'm going crazy thinking about this. Well, in physics, we cannot really speak about anything before the Big Bang. Clarification here, the Big Bang Theory says absolutely nothing about the beginning of the universe. I mean, absolutely nothing. It simply says, as far back as it goes, the universe was in a hot, dense state some 13.8 billion years ago. Before that, what happened, we don't know. If you do follow the theory of classical general relativity, it goes back to what you call a singularity, which we know cannot be true because it's a singularity. That basically, that doesn't mean something of infinite density or anything existed there. It simply means that our laws of physics fail at that point, the laws of classical physics, because relativity is a classical theory. So that's what as much we can say in physics. So the Big Bang theory, if you trust that, for which we have a lot of evidence, including the cosmic microwave background radiation, so it basically says that the universe was in a hot, dense state some 13.8 billion years ago, and we have absolutely no idea what was there before that. Sumit Sharma suggests any book of math necessary for understanding advanced physics. If I think you'll have to be necessary here. Advanced physics as in graduate and undergraduate level. I think you'll have to be specific there. Are you going to take any institution for your JE prep? If yes, which one? Atma. No, I'm not. Paiman, how is quantum physics related to astrophysics? I have interest in both. Well, I would say, I mean, I don't really know much about astrophysics. Truth be told, I don't know much about astrophysics, not specifically, and I'm not very much interested. I am quite interested in cosmology for that matter. Especially, I have had my interest in quantum cosmology. Granted, I still understand nothing about it. I mean, I tried reading Hawking and Hartle's paper, Wave Function of the Universe, and I did get a general idea of that. And but I don't really understand. I plan to specialize in that. That's like quantum cosmology is like the best thing I have come across until now. So I'm not very specifically interested in astrophysics, but I think quantum we do use quantum mechanics in astrophysics, considering we have to study star formation and all that, and so we have to take quantum mechanics into account. And so I do think we do apply quantum physics into that. I'm now going in 10th. Should I start completing 11th and 12th chapters by YouTube or by any book? What do you do? 60 FF. Well, if you do plan to study 11th and 12th, whatever subject, so you can try whatever way works for you. Personally, I study from books. In my case, I like to study from books, but whatever way works for you, just like go ahead with that. Make sure you solve the problems yourself. So that's the important part, and you must do that yourself. Divyang Bhoy, are you interested in computer science, data science, mathematics, and computing information technology, statistical analysis, applied or pure mathematics? Well, I do have to concern myself with applied mathematics, whether or not I'm interested in. I do plan to study pure mathematics. I have planned to study pure mathematics for a very long time now, but I've never actually got into it. I've always been busy with physics. So maybe I'll find my interest in pure mathematics, but at this point I cannot say. Parth Kumar, can sinusoidal AC current be zero in half cycle? uh, I have really forgotten much of current electricity. My apologies for that matter, so I cannot give an exact answer, but as from what I recall, it can be zero. I mean, obviously it falls to zero and then it falls to its peak value in half cycle, if you ask. So when you say half cycle, I take it such that it goes from its peak value at the beginning of the cycle, it falls to zero, and then the direction reverses, it goes back to its peak value. It definitely can. So here's what basically happens. One full cycle, I take it as it starts from its peak value, the alternating current, and it goes down and down and down. The value goes, and then it goes to absolutely zero, and then it continues. It the direction of the current reverses. When the direction of the current reverses, it goes to its peak value again, and then it starts falling from the peak value and it goes to zero, and the direction again reverses and it comes back to its initial peak value. This will be one full cycle. So in this cycle, we can see that it has twice gone to the value of 0. So it goes twice. Mars, which book is the best for studying physics in a simple way? All right. So, well, if we are talking about introductory physics, so I think books like University of Physics and Resnick Halliday, both Walker and Green, do a really good job doing that. For introductory physics, actual textbooks, supplementing those with the Feynman lectures on physics, that's like, so Feynman lectures are really good, like really good. They're masterpieces. So you can consider that. So, Ms. Sharma, for understanding complex physics, I have to study vectors at J advanced level, or just do I just go through only formulas? So, you'll have to specify what you mean by complex physics here, like J advanced level physics or higher. So, I don't really understand when you add in the word complex. Prashant Piyush, you should first achieve mastery in English before simultaneously pursuing mathematics and science. A strong command of English will aid you in writing your book effectively. Well, I don't really face any troubles with English. I mean, I really don't. All right, Divyang, boy, will you give J advanced? Will you give J advanced repeated? Well, yes, most likely I will. Is it better to be in India or outside for physics, Neelam Singh? I would say that if you are serious for research, there are most institutes in India that you could consider for research on for cutting edge research in physics. So it's like if you want to work on the front lines, so it's mostly outside. I would say in that case. Which coaching you want to join or self study predator? Self study. Sumesh Sharma for J Advanced Physics. So, well, for J Advanced Physics, it's like as much as you have learned it in physics, that's as much as needed. What questions you would ask Einstein? Aryan Mishra. So, if Einstein were in this time, it would be interesting to see his opinions on, well, on the violation of Bell's inequality. So, Einstein gave in 1935, published his paper alongside Nathan and Rosen. Can quantum mechanical description of reality be considered complete? And there they present the EPR paradox. And Einstein died in 1955, although Bohr wrote a paper in the same year with the same title in 1935 only, and there he tried to reason it. And then Schrodinger writes a paper, I suppose, in the same year or in 1936. So Schrodinger writes a paper, and there he first time he coins the word, terms it entanglement. So, but an actual satisfactory paper came out in 1964, and this was John Bell, and this was on the EPR paradox, written by John Bell. So, Einstein died in 1955, and Bell wrote this paper in 1964, and Bell presents what is we call Bell's inequality theorem. And Bell basically presents with this theorem that any local hidden variable theory, as Einstein, Podolsky, and Rosen imagined, any local hidden variable theory cannot give us the same statistical predictions that quantum mechanics does. And so, if you verify it in laboratory, if the predictions of quantum mechanics are correct, it means local hidden variable theories cannot exist. So, if there has to be a hidden variable theory, it has to be essentially non-local. So Einstein wasn't really alive to see the Bell's inequality theorem, and we have well, physicists have tested Bell's inequality, and that was, I suppose, what the Nobel Prize in year 2021 or 22 or 23 was. I don't exactly recall between these three numbers what that was for. And well, quantum mechanics, the predictions that we have from quantum mechanics, the statistical predictions match what we expect, what we saw in laboratory, right? So in that case, we know that local hidden variable theories cannot exist except for one case. That is one case, what we call super determinism. So that will does not exactly violate Bell's inequality theorem, but is based on that there is this assumption, unvalidated assumption in Bell's inequality theorem that you absolutely cannot validate. So that's a whole another matter. But it would be interesting to consider what Einstein would think about this if he saw this.
If two questions they could talk.
Prashant Piyush, I apologize for asking this. If you obtain a lower rank in J Advanced, will you abandon your goal of becoming a theoretical physicist? No, absolutely not. Uh, Brother, please tell me how we can master mastery in math. Namaste, Karan Singh. Namaste. To achieve mastery in math, I cannot say much from the mathematical point of view. I mean, I personally kind of suck at math at this point. I do have that kind of mathematical talent more so than in physics. I like to believe that. I mean, I did study mathematics properly in the beginning, but I have been away from serious math for a while now, and I don't have any mastery in math, that I would say. Still, from what I have learned and from what applied math and mathematical methods I have learned that I apply in physics. So it basically comes down to you need to understand the things and you need to prove them and solve the problems. That's basically how it works. It's like understand the things and solve the problems and proofs if you're doing serious math. How to do 11th, 12th physics and math in class 9th, part Kumar. The same way in how you do 11th and 12th physics if you're in 11th and 12th. It's like pick the book, maybe you want to add it with some lectures and solve the problems. Read the text and solve the problems. Priyanka Sharma, are you a professor? No, I'm not a professor. So I hope I could be a professor in some esteemed university one day. Sumesh Sharma for J Advanced Physics suggests tough book for physics. I think it goes Erodo. Hey Badya, I'm Aditya. Also, a 10th grader is going to be in 11th grade in a month. I was wondering if we'll give IIT or an NEST to get into IASCRs and NISCR. So this is by Swins North Spinch. All right. So I don't have any plan for IIT or any NEST currently. Not any plans for ISCR and NISCR. If any university, if any institute in India, I'd rather go for IASC. Uh, Priyanka Sharma, by the way, I'm INMO qualifier of previous year. Wow, now it's my first board year. Wow, congratulations. Is nuclear force always attractive? Parth Kumar. No, it's not always attractive. So it's like a spring if you try to model it classically. Though I would say it's like to model things classically, it gets really. It's only an analogy that if you try to, let's say you have these two things bound together by nuclear force, so these two elementary particles. If you try to separate them, then they try to attract each other and come to a stable equilibrium here. So it's basically in a stable equilibrium. If we try to push them together further, then they will repel and you leave them and they'll come back to this place again, to the place of stable equilibrium. So it depends on whether you're trying to push them apart or pull them into each other. Pull them apart or push them into each other. Bhai, from which class you're studying high level or 11 level physics, Rishabh? When I passed fifth standard. Bro, do you know about TIFR College, Akriti? Tata Institute of Fundamental Research, obviously. Yes, I do know. In fact, I read of some latest research from there only. Don't recall. I mean, I read it day before yesterday only, but I already forgot what that was. And ironically, I recall what college it came from. So, yeah, I do know obviously about that. Vector algebra, differential equation, integration. Which should I study first, Sumesh Sharma? I think you can go ahead with vector algebra, then integration, and then differential equation, because you basically need the concepts of integrals and differential equations, right? So there we have that. But then vector algebra is easier, so it can provide for some foundation in this. So vector algebra, then integrals, and then differential equations. What topic should I do to cover my basics, which I get from schooling? Chaitanya Mathuria. Well, depends basics as in which standard. If it's like in 11th standard, so in physics, so it's like you cover mechanics. In mechanics, I will say you need to know how units and dimensions work. So dimensional analysis and kinematics and Newton's laws of motion. So those are the basics. And on the basis of that, everything else builds. And also adding vector algebra, of course. So my question is, why do we need to go into higher dimensions for the analysis of string theory? Preeti Pushkar. Well, the thing is, the string theory does not work in our in our 3 plus 1 dimensions. 3 plus 1 as in 3 spatial dimensions and 1 time dimension. So the theory does not work in these dimensions. That is actually the concept of introducing higher spatial dimensions does not first come from string theory. It comes from Kaluza-Klein theory. So, or Kaluza-Klein theories, you could say. So Einstein models gravity as the curvature of space-time, as the geometry of space-time. So Kaluza comes along. I don't know if it was first Kaluza or it was first Klein. I suppose it was first Klein. So Klein comes along and he tries to model the electromagnetic force that way. And he says that to actually model the electromagnetic force that way, you'll need to add in an extra dimension. The problem is that the electromagnetic force, gravitational force, is well universal. It's absolutely universal. It's attractive for all masses and it doesn't depend on the mass of the object, the gravitational acceleration of object, right? So whatever mass of a particular object is, well, consider you throw a ball on earth, so whatever be its mass, it is going to fall with the same rate of acceleration. Due to this very fact, and due to that masses always attract each other, you can model gravity as a curvature of space-time, where space-time is the background on which you do physics. So that's the background, and you can throw your gravitational field on this background, right? But you cannot do that with electromagnetic force, because the electromagnetic force depends on the nature of things that are attracting or repelling each other. It depends on the nature of that matter, so you cannot model it unless you introduce an extra dimension. So Klein introduced this extra dimension and he worked it out. And string theory works in the very same way. So if you want to have strings instead of point particles, for the mathematics to work out, here we get into mathematical technicalities. For the mathematics to work out, you need to introduce these 9 plus 1 dimensions. That is 9 dimensions of space, 1 dimension of time. And then Ed Witten comes along, so the super genius, and he unifies all the different string theories into one theory, the M theory. So M theory is like, his colleagues suggested the name M for membranes because he introduces these concept of membranes. And he also invents another form of string theory and again unifies it with M theory. And for M theory to work, now you don't need 9 plus 1 dimensions, you actually need now 10 plus 1 dimensions. The thing is, to go into these extra dimensions, to travel through these extra dimensions, you need an enormous amount of energy. Like, and this thing, you can just search up a YouTube video over it, the Schrodinger equation solution for particles in a circle. And this also shows up in that concept of supersymmetry. And string theory, turns out, does not really work out perfectly well without introducing supersymmetry. So you need supersymmetry for string theory to work properly. It's big brother string theory. That is like that engulfs string theory, you could say, for that matter, to work properly. And supersymmetry should have been detected at CERN, but there have been no traces of supersymmetry. So that's one reason to be skeptical about it. So, in principle, we should have discovered it at CERN. Parth Kumar, does electrostatic force applied by a point charge on another point charge depends on the medium? Yes, it absolutely does depend on the medium. In fact, the electrostatic field itself, so the field itself depends on the medium. And it depends on the medium, such as if you have a medium of greater dielectric constant, the electric field is going to be smaller. That's how. And why exactly does it depend on the medium? Because, well, the medium is going to have its own electric charges, and so due to that, electric fields will be induced inside the medium, right? So when you have electric field that is piercing through this medium and there are charges in that, so they are going to induce their own electric fields that might cancel it's this electric field. So if you have, if when it's canceling some part of this electric field or reducing it, because it's fundamentally a vector quantity, so you have, if a medium of greater dielectric constant, the overall electric field experienced on the second charge between the two of which the medium of this particular dielectric constant has been placed is going to be reduced. I have made a question. Will you please try to solve it? I'll send it in comments in your new video, please. Vivek Yadav dot 17. Sure, you can send. I'll try it. Is Ramanujan summation of sum of natural numbers till infinity true? This is asked by Sumit Sharma. The way it's interpreted, not. I mean, I don't really understand it much. I mean, that has to do with pure mathematics. I think it has to do with something with Riemann zeta function. And so Ramanujan actually speaks about that zeta function and he says for this it's going to be minus 1 over 12. But the way it's interpreted that the sum of all natural numbers till infinity is minus 1 over 12, it's like, no, that's rubbish. The sum of all natural numbers until infinity is infinity. That's simple. Ramanujan summation does not say that. According to you, are the students who secure an all India rank under 100 or 50 comparable to your intellectual ability, superior to it or inferior? What are your thoughts on it, Prashant, Piyush? Now that's a risky question there, and well, surely a risky question, but I'll be honest on that matter. I don't know, and I don't really care. I mean, comparing one person's intellect, and these are my true thoughts, really. Comparing my own intellect with someone else, or vice versa. So they are, well, basically doing good in their what do you call it, speciality, not exactly speciality. They well prepared for this exam and they're scoring higher under hundreds or under 50s and they're doing really good. I am on here planning to specialize in physics, so I have a different thing. So these are two different things entirely. Okay, both, tell me why you don't compete in RNMC, Ramanujan National Maths Challenge. Ati bhai, well, this is the first time I'm actually hearing about the challenge. Sorry, I didn't know. Are you working on any project or plan to publish any research papers while you are still in high school? Spins not spinge. Well, or truthfully saying, I do plan to, but it's difficult. I'm to even catch up to things up to the front lines, so that's like really difficult to even catch up. So there are lots of things that I'm interested in, but again, it has to do with research takes time. I think the chart here doesn't show properly. Yeah, please suggest book for physics and chemistry. Nanika Gupta. Chemistry, I really cannot say. Physics, I think HC Verma is good. I mean, that's the standard. Go, you can go ahead with it. But depending on what exam you're preparing for, or whatever, you can better ask teachers who are specializing in those areas, so who are more experienced. So from my point of view, HC Verma is like really good. Caracal and ice cube with an embedded cork floats in a cup of water. If all ice melts, will there be any change in level of water? Your answer would be appreciated. No, I don't think so. Unless you're considering, is the density of ice different from water? I'm afraid I don't really know much about it. Is the density of ice different from water? Because if you consider them to be same, then there will be no change in the volume of water, considering mass is well going to be the same, so same buoyancy and all that. So all that does, you don't even need to get into the mathematics. The water level should be the same. Shreyas, are you studying one about quantum mechanics? Because I'm also studying about it being in 10th. Well, I do have some knowledge of quantum mechanics, and yes, that's what exactly what I'm studying right now. So I plan to, well, at least master, not exactly master. I plan to study these areas that help me further in studying quantum cosmology mainly. I was interested in foundation my brain. I mean, the measurement problem was reading about that, interested in that, but it's just simply